So Jenny, maybe let's get started. Can you hear me?
Yep, let's get started. Welcome everybody to our webinar today. At the end of this year, it's been a very monumental moment, probably for everybody. And I believe that everyone has made a lot of achievements throughout this year, and so did us at Milvus. And James has actually led our team and made a lot of upgrades to our product, and he is very excited to show us what's happening with Milvus 2.6 today. And before the session starts, I like to have a few notes. So first of all, this session is being recorded. So the recording will be distributed to all of you guys through email after the session ends. So you can review all the details and everything about it. And second is that we will have a Q&A section at the end. And also, if you have any questions, you can raise your hand or just type in the chat. We can, as long as we see your question, I will let James know and jump in. You can jump in and ask that question, and James will let you know about the answers. And of course, feel free to use the chat area and to chat for general questions or the questions that you might have. Um, so let's get straight to James and let's have a introduction of James. So James is our VP of engineering here at Zilliz, and he has very deep expertise in database architecture and has been instrumental in the evolution of Milvus. So today he's going to give us a very detailed breakdown of the 2.6 upgrades, which is very exciting. So let's get straight to it. So are yours, James?
Sure. Thanks, Jenny. Thanks everyone for joining us. So, Milvus 2.6 is actually released more than 4 months. During the last 4 months, we actually spent a lot of time to make it stable, and we also like put a lot of new features into it. So, right now it seems to be is kind of like already production ready. We've already seen a lot of customers on this cloud actually using that. So. Uh, Hopefully you can get enough information about 2.6 and you can find something you really need. Okay.
Hi,
Uh,
James.
yep.
Actually, sorry to interrupt. There's already a question here at the Q&A sections I'd like to ask about it.
Sure.
So one of our attendees is asking, is there or will there be a graph database extension to hold a knowledge graph? Well, we covered that in our presentation.
We won't, but yeah, to give a short explain on this, I think we are working on some graph embedding strategies. So instead of convert, like I know GraphRag has become more and more popular. So, but instead of like becoming a graph database, what we're trying to do is actually we have this data lake project where we try to do a lot of batch processing, do create graph for people, and then we convert those graph into graph embeddings and use vector search to do like relation search. But it's not like traditional graph database exact match. It's more like doing graph embedding search. Yeah, get to talk more about those details, uh, but maybe after the session. Yeah. Okay. So going back, so today's agenda, first of all, we'll do a quick introduction about Milvus Zilliz. I'm pretty sure most of you guys has knowledge, but so we quickly go through it. Then we talk about four major improvements for Milvus 2.6. One is better data model. We actually customize our data model to make sure that a lot of the rec use cases, a lot of the semantic search use cases uh, becomes much easier for user to use. Then we added a lot of search functionalities to make because we see a trend that more and more OpenSearch and the Elasticsearch user is actually migrating to Milvus, and we also see some like functionality mismatch. So we try to add more search functionality into Milvus 2.6. Yeah, third part, as always, is always performance cost optimization, and last part is some architecture change to make Milvus a little bit easier to maintain. Yeah. Okay. Okay. So for Milvus, this is the famous open source one. We built it like for almost 6 years. Vector database helping you to store, index, and manage all your vectors. Right now, the community is actually growing very fast. We see more than 400 contributors. Uh, for the last couple of weeks, it just bypassed 40K GitHub stars, and we see more and more users to actually use it in production. Right now, as far as we know, we see more than 10K enterprise users who are actually using Milvus in their production environment, and we see this number still fast growing. Yeah. Uh, Zilliz is actually the company behind Milvus. We actually did both open source and our fully managed version on the cloud. So our product name is called This Cloud, and it's actually a leader in the first wave vector database providers report. Yeah, so our goal is just to helping organization to make sense of unstructured data. So it's not only about vector base. I'll talk about our vector lake solution a little bit later. But right now, we try to build a stack for people to better processing of all the unstructured data. Okay. So quickly show our logos. We do have a lot of like cool logos across multiple different industries. Mostly their use case is just a semantic search and RAG, but we're actually seeing more and more different interesting use cases in production. So if you have a interesting use case where you don't know whether like Milvus can be your choice, we definitely got to talk to you. Yeah. Okay. So first topic about our data model. The first thing I want to mention is we actually introduced a new struct data type. So I think originally Mu is more like a white column databases where we actually split data into each entities or rows, and each entity has multiple different columns. So that is perfect for table schema. But when you do reg, you soon find that sometimes you just need a nested document. For example, if you do a PDF, you want to convert the PDFs into multiple different token embeddings if you're using things like Cobert or Copilot. If you're doing a text rag, you probably see you want to do chunking, and each text is actually split into multiple different chunks, and each chunk also has meta information. You do video, you can have frames, and each frame has its own embeddings. Sometimes each frame has multiple embeddings if you do object detection. Yeah. So similar thing happens. We saw this very common pattern for all the unstructured data. Uh, so you need some kind of nested data structure. That's why we actually introduced struct. So uh, there are like two common patterns. One is to, for example, using multi-vector. So when you're using models like Cobert and Copilot, what you always do is actually sending your, for example, images or text into a multi-vector model and actually generate token level embeddings. And when you search, you're actually using like late interaction using a maximum matrix. The good part is using these late interaction models, you actually get a very good recall, and it also natively multimodality. That's why a lot of people, like for the last couple of years, they ask for Copilot support. Um, but the bad part is, first of all, it's just too expensive because original density embedding is like chunk level. So each PDF probably just 5, 10 embeddings. But if you actually extend it to token level, you definitely see more and more like embeddings. So compress becomes very important. And the other part is that performance also become big headache. So we did a lot of optimization on that. So if you do maxim metrics on Milvus 2.6 with the struct implementation, you definitely see much better recall as well as performance compared to the original implementation. Yeah. So we do have a document talk about how to using Cobert, Copilot together with the struct data structure. So feel free to just search with our Ask AI on Milvus webpage. Yeah. So the other basic implementation is chunking plus some meta information. That is also pretty common for all the reg use cases when you have one, let's say, text information, but it's longer, so you cannot fit those into the token window. That's why you have to split into smaller chunks. Each of those chunks all has multiple embeddings. If you do like have research, you may have a dense embedding, you may have a sparse embedding, and they also have a bunch of meta informations. So meta information is always used to do filterings, and it's basically just do filterings, do a hybrid search, then you do a group by. That's a lot of like existing Mills users trying to use that, but group by is usually slower. And for many of the use cases, all the data is immutable. That's why if you're using struct, what you can actually do is put all the entire document into one row. So instead of group by, it's actually natively do group by for you, and the performance is even better. Also, you get a lot of uh, like transaction support. So when you do ingestion, like all the data will be shown at the same time. Yeah. So um, if you have like traditional use cases, you already using like group by in previous image versions, you may want to migrate to the new structure information. And the good part for it is um, since it's a nested document, if there are some meta information actually shared between multiple different chunks, you don't have to like duplicate it. If it's a traditional like table implementation, even at some like meta information is like document level, you still have to like duplicate multiple times, and that help you to save a lot of like storage space. Okay. So next big thing I would say is location aware. So basically, what we do at the Milvus 2.6, we actually support a new data type called geolocation data type. Yeah. So during the last couple of years, we see so many use case to combine vector data with multiple different data, and geolocation is one of the most popular one. We do have companies like DoorDash, and when they are doing their delivery business, they want to first filter locations. Say, I only want to find a restaurant near San Francisco, like in 10 miles. That's why you always start from geolocation filter, and then you do a nearest neighbor search for your recommendation or your search business. Yeah. So in 2.6, we actually introduced this geometry data type, and we also support to build a spatial index. Basically, it's archery index on top of it. Yeah. So with this, you don't really need to maintain two different systems. And also our archery implementation is actually well optimized. So we see like compared to even like domain specific build geolocation databases like Postgres, we still see a great performance improvement. Yeah. So even if you're not doing like strong vector search requirement, just using the geolocation filter, I think is going to be give you enough like performance and cost efficiency benefit.
Thank you for it, James. Jumping in real quick, there are two questions in the Q&A section.
Yeah. Uh, yeah, maybe I think maybe we're just going to answer all the questions in the end. We just leave like 10-15 minutes, so that could be a little bit better. Yeah.
No problem.
Um, so time next big thing is time array modeling, because time is actually going to be very important for when we build agentic applications. One of the most because first off, when we migrate a lot of data from traditional relational databases or data warehouse, what they usually have is a datetime field or a timestamp field to indicate where the data is actually modified and probably written. And originally, what we can ask people to do is just converting this into uh, like long or into 64. But this is still hard to read and hard to manage. So we actually introduced this timestamp TZ data field. And the best part for it is it can be also working together with Mil's time to live feature. So uh, the data can be automatically expired after a certain time. So one of the cool feature we are still building and will be released pretty soon is integer level TTL. So originally we have is more like a collection level time to live feature, but I think in the probably next month we'll have the integer level time to live. So basically means when you're building multi-tenancy use cases or you might want to just set a different time to live for different type of document. For example, some of the document, for example, my code base might not never be expired, but some of my memory will have to purge it after like certain time, and you can always put all your data into one collection and specify different time to live. Yeah. And of course, we are not only trying to like expire all the data, but sometimes we really need a decay function. Like the newer the data, it gets more importance. The older the data is actually fitted away, just like our brains. Yeah, that's why we supported a new mechanism called decay re-ranker. So so the basic idea is we have a timestamp field, and the search relevance is actually decreased when time goes by. Like the longer you actually ingest the data, the less possibility is actually going to show in the result. Yeah. So there are a couple of interesting use cases. For example, when you build agent memory, the decay ranker can help you to work as a forgetting mechanism. And if you're doing news, of course, the latest news get them the most weights to recommend to the users. If you're doing e-commerce system, you have some trending items, so you can updating its weights. So even if it's not the like most popular one, but it's still like if it's a trending one, you can still get better rates compared to other products. Yeah. Okay. So next big thing, we'll talk about schema change. Yeah. So original Milvus is like a pretty stable schema. There's no way you can alter a collection, adding a new column into it, or drop a column. So one of the biggest improvement I would say for 2.6 is we actually supported alter table and add a new column into it, and you can specify whether you get a null or you get a default value for this new column. And the other feature we'll be working on is actually backfill from existing table. So no matter if your table is already in Iceberg or it's probably in other databases, we once you add a new column, we can help you to backfill the new column with your existing data on Iceberg. Uh, to work to implement that, you need a Spark cluster. We do have this new Spark connector implementation in 2.6 as well. So the Spark will help to read from Iceberg and prepare the data for Milvus, and Milvus actually doing a join operation to combine your existing data with new added data or new added field from Iceberg. Yeah. So with this new feature, it actually gives you a lot of flexibility. So you don't really need to like create a new collection and migrate everything to a new uh, collection. Instead, everything will be happens in place, and it actually avoid a lot of trouble on stop the traffic. Yeah, that's like a lot of people are just like complain about, especially on multimodality search. I think people are just trying to keep adding new features or new tags into the collection. Yeah, and for the follow-ups, I think in the next couple versions, we also support job field and alter collection index in the flight. So you probably definitely see more and more functionalities helping you to improve the maintenance costs for mules. Okay. The other one I want to highlight is data duplication. Yeah. So for the last 2 years, we see a lot of new cases designed for model training or model fine tuning. Data duplication is, of course, one of them. So we see large demands, like people actually crawl a lot of data, no matter it's text or multimodality data. And those data is not super high quality, so that's why they need to do a duplication before they actually do training. Yeah. So we actually implement min hash uh, locality sensitive hash algorithm. So you helping people to do all the data duplications. Right now it's only about text, but probably in the next 1 or 2 months, we'll also have a new version which can implement for both videos and images. Yeah. So the duplication is actually split into two parts. The first part is offline, and you can just start a Spark job to execute like full duplication. And after that, you build index on top of all your already duplicated data, and the Mules can help you to do the streaming part. So what we usually observe is for every time like you try to do duplication, it usually you have to do it like every 3 months or 6 months. You have to do a full duplication. Then after that, each of the day you have some update on the data or modification on the data. Then you do a streaming deduplication. Yeah, so with Milvus and Spark working together, you can do both full deduplication and streaming deduplication in one system and using one storage, and that help you to reduce a lot of cost to maintain this complicated system. Okay. So that's the first part. You see that we do a lot of functionality improvements on catering the needs for all the AI applications. And next part, we're going to talk more about search. Yeah. The first thing I want to mention is Mills finally did all the integration with some of the cool embedding models. I think this is nature, but for some reason we want really to focus on vector database in the last couple versions. So we keep telling people you should have your own embedding vendors and just integrate with their APIs. And Milvus is only going to take care of your embedding data, not your raw data. Yeah, but I think things actually change quickly because first of all, a lot of people is asking about this, and especially for open source users, sometimes we just want like one-stop solutions because people don't have enough knowledge about like Kubernetes and they want to deploy their embedding inference engines together with their vector search and for all the end users to just ingest their text or images instead of like thinking about what kind of embeddings we are going to be using. Yeah, and they also like if you deploy your embedding models together with your vector store, you should also see better like lower latency and less network overhead. Yeah. So right now we do have supported embedding as a function. So you have two options. You can use third party, which is things like OpenAI, like Vertex AI. You can directly calling their APIs. What you always need to do is just to set up your password um, and we'll help you to call OpenAI to get all the embeddings. So that is one way to use that, and we also have a self-hosted mode. So right now we supported inference engines like Triton and will.am. We also support some of the like open source embedding models such as BGE, Queen, Gina embeddings are probably going to be like more, and we'll keep updating all the embedding models. So uh, you can also like bring the inference service together with the Mills Kubernetes operator. So you don't really need to worry about how to manage those inference engines if you're not expert. So the open source operator help you to do that. Yeah. And of course, it's not only about embedding. The other part, very important for RAG or search, is re-rank. So we also support like re-ranking models as one of the Mills operators. We support SAS level. You can do Cohere, you can do WorldGI, you can do OpenAI, and also you can use TEI, the Hugging Face inference engine or WLM, to do re-rankers as well. Like we supported several open source re-rankers. Yeah. Okay. So the other one more interesting is boosting. So instead of using larger models, sometimes people just want better control with some like specific fields, scalar fields. For example, I want like people between age 20 and 30 to get a better relevant scores, or I want data with uh, hottest data to get most of the relevant scores. So maybe you have a few uh, called hot read. Then the higher the score, I want this item to be show more on the search result. Yeah. So Boost actually helping you to implement a feature that you can specify an expression and give them actual rates when search happens. Yeah. So the use case for Boost is usually promoting, for example, fresh contents, downrank some low-rated items, or uh, like boosting some of the documents that actually freeze matched. Yeah. So it actually runs after nearest neighbor search. So when we do nearest neighbor search, we actually search for more candidates. Let's see if you ask for top 10, what you usually do is we actually search for top 100 or even a little bit more than that. And then for the top 100, we're actually using the specific field you specified to re-rank or boost the uh, or change the relevant score. And after the refine, we get the final top 10. Yeah. So with that, so if you're using model re-rank, is more like helping you to improve the relevance. And if you're using Boost, it always like understand your business better, and you can set specific rules of which items actually get a higher priority. Okay. So the other interesting feature is freeze match. Sorry, the diagram may be a little bit too small, but if you're familiar with text match, when you do filters, you can specify I want to search uh, a text with keyword San Francisco. That is what they call as a text match. And freeze match is even more than text match. You can search for San Francisco city, like San Francisco is one keyword, then city might be the other keywords, and I want to search for only when both San Francisco and city is actually, or San Francisco airport, both San Francisco and airport is actually showing the text. Yeah. So the freeze match can be used on both filter, and it can also use in the boost. So for example, if you get keywords San Francisco and airport in their search, you might have more priority. Or I only want to search for documents with with both keywords San Francisco and airport. Yeah. So the freeze match use is very easy. It's exactly the same as what you do as text match. Yeah, we just add a new keyword into our like filter expressions. Yeah. Okay. Uh, Last thing for search is highlight. If you're trying to build a search system for people, how you explain and visualize the results is actually very important. Yeah. For example, I have a document which talk about Milvus, and when we search AI native search engine or vector search engine, then people probably want to see why this document or why this corpus become the final search result. Yeah. So then with the highlight feature, we actually highlight keywords like search engine, AI native, uh, also retrieval might be the keywords. Yeah, if you search on re-rankers, then of course model re-rankers become the keywords. Yeah. So right now we support two different type of or two different flavor of highlights. One is what we call the keyword highlights. So if you search for AI, then AI becomes the keywords, and we actually helping to highlight AI. But the other one we call is a semantic highlight. So we are not highlight only the like keywords you are searching for, but we are also trying to understand your semantic and find more like relevant keywords. So if you search for iPhone, you might also get MacBook as a highlight uh, because they are like semantically speaking relevant. Yeah. So We supported both style, like keywords. I think they have a lot of existing usage on when you're building a search system, especially some e-commerce search. You probably want to highlight why people like this. If they search for right, you and in your like uh, uh, description, you might have some color descriptions, and it might the user search red, and you want to highlight this part to notify people why I actually give you this result. And semantic search, I would say is more like when you're building AI agent, before you send all the documents into search like into your search system or into go to your larger models, you probably definitely don't want to send the entire document into larger models. And semantic highlight also help you do semantic context streaming. So only the most important part is actually sending into the larger models. Also help you to save some tokens. Okay. That's for search. Third part we will talk about the performance and cost optimization. Yeah. One of the most uh, exciting part for 2.6 is RabbitQ, the new quantization we actually introduced. So I don't think I want to get into too much details about what RabbitQ is. Feel free to read about the paper. The idea is all about you use some features for high dimensional data and try to improve the quality or kind of like reduce the recall loss for quantization. Yeah. So after our test, like for the 1 bit quantization RabbitQ, like compared to the original binary quantization, it actually increased your search accuracy to more than 10%. Yeah. And compared to like product quantization or the scatter quantization we have, it also improved the performance a lot. Like compared to product quantization, we see like RabbitQ is like 2 or 3 times faster on search. Yeah. And if you do 1 bit RabbitQ quantization together with refine, you can still get a very good recall, like more than 90%, or even on the OpenAI dataset, you can get around 95%. So the recall loss is definitely acceptable, but it helps you to reduce your memory usage by 30 times. So RabbitQ is already on open source, can be working together with ACW, and I think LVF is actually also support this RabbitQ. We do have a special version of RabbitQ on this code, which we actually support multiple bit implementation. So it got higher recall than like the open source 1 bit version. So if you're seeking for better performance and great trade-off between like memory usage and performance, do definitely think about this code. Our auto index actually has the newest quantization algorithm from our research team. We try to release it step by step to the open source as well, but yeah, if you have large use cases, definitely think about like at least test or doing POC with us. Okay. The other big part is tire storage. Yeah. So, as you may know, Milvus is already like a distributed system, and we do computation and storage disaggregation. So all the data is original stored in S3. Yeah. So, but before 2.6, we need to caching all the data into local storage or into memory before we serve. Yeah. So 2.6 actually introduced a new architecture, which we call tire storage. So for the code data, we actually uh, put all the data into S3 instead of loading it so that help you to reduce your memory usage and local disk usage. And for hot data, we're actually caching it uh, inside your local disk, and you're actually doing a like swapping swap out. So right now, for each of the collection, you have two modes. One is fully load mode, and the other one is tear storage mode. Yeah. So that extremely helpful if you're trying to build RAG applications or multi-tenancy use cases where most of your users could be just code data, and there's no reason to let the code users to uh, take all your memories. Yeah. So for all the hot data, you can still get less than 100 millisecond latency and probably 100 QPS. So it's pretty fast. But for the cold data, query latency is probably going to be much longer, like based on what kind of storage you're using. So, but we're still expecting for like less than 1 seconds for smaller tenants, usually several hundred milliseconds for smaller tenants, and for large tenants, usually like 1 or 2 seconds. It's still not bad for many of the rec use cases because the large language model is uh, no matter what can be slower, so doesn't really matter if the vector search latency is a little bit longer. Yeah. We do have another version of Terra storage on the cloud as well. So the performance is actually uh, better, but the idea is actually going to be the similar. So we already seen several open source users taking advantage of Terra storage and helping to reduce their like storage cost by 5 times. Yeah. Okay. Third thing we want to mention is acceleration on the filters, especially for dynamic fields and JSON. So if you're already using JSON filters in your production, you might see it's become slower based on what your dynamic fields looks like. The larger the JSON fields, the slower it is. So Milvus 2.6 introduced two important mechanisms. One is what do we call it? JSON shredding. So instead of store the whole JSON into a large field, we actually split it into multiple different fields. And for They called tabbed columns, they call dynamic columns, and also shared columns. Yeah. So for tabbed columns, it's if every entity has the same field, we actually store it in in a static field, and we also when you filter on it, you can fully utilize SIMD. You can do similar as what we have as other like static field. So you can just using the column storage. Yeah. For shared type of columns, if like for example, each of your JSONs are like they have different case and the case have maybe different data types, then what we actually do is actually building inverted index on top of all the data. So if you search for pass AA, then the first thing we do is actually go through all the inverted index, try to find which entities have this pass AA, and we only parse those JSON document and filter on several like entities instead of like originally what we do is actually parse every JSON, find if there is a AA pass, if there's no, we skip that, and then match the value. Yeah. So for shared column, it only happens if your pass is sparse, like less than 10% of your entities actually have this pass. Yeah. So if you see this result for shared case, we actually get more than almost 100 times of performance improvement, and for type case, we get between like 50 to 30% of the performance boost. Of course, it's based on your how many columns are there in a dynamic field or JSON. But no matter like what kind of uh, data type you guys use, you will see a strong performance boost when you enable shredding features. It's not enabled by default, so you have to enable with specific parameters. Yeah, check every document if you do want to enable it. And with this JSON shredding feature, it usually means you can heavily depends on dynamic schemas rather than fixed schemas, and that gives you a lot of flexibility because even like 2.6 supported add column, it still take you some time to add a column. And with dynamic field, you don't really worry about your schema. Just use it as similar to MongoDB and don't really worry about any schemas. And if you saw JSON shredding is not fast enough, sometimes filter could be still slow. We also support to build inverted index on top of JSON. just like we can do inverted index on top of any kind of your uh, like static or fixed schema field. Yeah, so if you build index on top of it, it helps you to further like accelerate your traffic. The other important index is ngram index. Yeah. So we've seen like with the agent use cases, a lot of people are just trying to do more likes operations or yeah, I think it totally makes sense because when you see what actually Cloud Code and the other agents are actually doing, they did a lot of grip. Yeah. But like for like any of the other databases, like could be super slow, especially if it's not prefix. If it's suffix or if it's substrings, especially with wildcard, it could be super slow. We see like a lot of users try to use that in Milvus before 2.6, and the latency could be even more than 10 seconds. Yeah. So we create this ngram index. How when index building happens, we actually split the text chunk into smaller gram, like 3 gram or 4 gram, and we actually build a gram index on top of it. So, for example, if you have a keywords database, then we split the database into DAT, ATA, and TAB. So those are like 3 token uh, chunks. And for each of the chunks, we maintain an inverted index, telling users what is which document actually includes this 3 gram. Yeah. And when you search for a database, what we have to do is actually split that database into ngram as well. And for each of the ngram, we search for the doc ID which has this supported, and we merge all the doc ID lists together to find a final candidate list. And using the candidate list, we retrieve the original data and run the lag operations. So it's actually helping us to filter out many of the like unlikely contents database corpus. Yeah. So we'll see that with this ngram feature, it helps us to accelerate around 100 times with like brute force search. Yeah, but the only thing to you need to consider is like with the ngram filter also increase the memory usage. So if you create it on your long context, you should see that your memory usage like increased, probably doubled or even tripled with 3 gram or 4 gram. Okay. So last part, we probably going to quickly go through all the architecture change for 2.6, but this part should be really quick. Yeah. So I think if you're familiar with Milvus, originally we have 3 nodes: query nodes, data nodes, and index nodes. Of course, we have proxy and coordinators. So in Milvus 2.6, we actually merged index node and data nodes into one node. So the new data nodes actually help into processing compaction, index building, and bulk insertions. We actually introduced a new node called streaming node. So it takes part of the original responsibility from data node. So all the new data before they ingest it into red data logging, it actually first go to stream node. And when search happens, stream node is actually responsible for serving streaming uh, data, and query node is only responsible for serving historical data. Yeah. So with the new stream node introduced, I think there are actually several big advantage compared to the old one. First is that we'll be able to support some of the stronger guarantee, for example, the transaction, for example, with the strong consistency mode, you see a great performance improvement of strong consistent mode because right now both stream read and stream write happen in the stream node, so we don't really need to wait another like 200 milliseconds to make sure that um, streams like strong consistent search get a guarantee that all data is arrived at query nodes. So stream node has the view of our streaming data and consistency, strong consistency become much faster. And the other good part is like it becomes easy to do load balancing because originally we put all the growing data and cell data into kernels, and they actually too uh, like growing data is very special. It's much slower than cell data, and also it takes more memory, and it keeps growing. So it's very hard for engineers to write balance algorithm for both data. And right now, like since we split the growing data and the cell data into different nodes, writing balancer algorithm has become much easier. So you should also see your memory usage improved after you split all your growing data on the cell data. Yeah. So that's the biggest improvement we see in 2.6. Uh, the other one is Woodpecker. I'm pretty sure some of you might already use it so it actually released back to 3, 4 months ago. Woodpecker do have two modes. The overall goal for Woodpecker is just to remove Pulsar or Kafka from our dependency list and reduce the maintenance cost. So they have a memory buffer mode where you don't really need to introduce any other like node. And Mills directly read our Red Hat logging onto S3 or onto me now. So the good part for this mode is actually very simple, like no actual dependencies. And the worst part for this is the write. You should see the write latency become higher because we try to group writes for S3 to reduce the put cost. Yeah, so the group window is usually 200 milliseconds, so which means for each of the insert, you should expect your write latency to be a little bit more than 200 milliseconds. Of course, you can tune it, but I think it kind of like based on like how your object storage is actually getting charged. But usually, I think the reasonable group window should be like between 20 milliseconds to 200 milliseconds. Yeah, the lesser the group window, you can get the better performance, less latency. But on the other side, you try to frequently write it into S3, and you get to be charged more. Yeah. So to solve the performance issue, we have another mode which we call as a calm buffer. So it's still three nodes, exactly similar to what Bookkeeper does. This mode we are going to release in the next probably big version. It's not ready in 2.6 yet, but we already have the code there. So with the calm buffer mode, we do a calm write to three Woodpecker nodes, and Woodpecker just produces all the data onto local disk, and the batching commit to S3 so the local disk is using the red caching, so you get very good latency. You can still get like single digit millisecond latency on write, and but Woodpecker just to store some latency data like for the last 10, 20 minutes, and after a while they still like group all the data and commit into object storage, and that makes Woodpecker very easy to maintain because although it has some state, but it's almost like non-state because it only maintains a latent minute state. So your failure recovery become better, and when you try to replace a node, you just send a command to first commit all the data to S3, and then you can easily like just add another Woodpecker or remove Woodpecker. So this mode will be open source and probably in the next 1 or 2 months. Okay, so third important thing is we actually put CDC into part of Milvus. So we start to support CDC back to 2.4, I believe, but this is actually a separate repo. So we see multiple different issues if it's not actually in the kernel. And when kernel did some major refactoring or modifications, like people usually forget to maintain the same thing for change data capture. But for the last couple of years, we see more and more business critical use cases, and people are asking for, can I do incremental backup? can I do replication between two Milvus clusters, how to do high available, how to sync my Mills data into my data warehouse. So we see more and more of those requirements. Yeah, so that's why it make us to think and finally make the decision to put Mills CDC as part of the Mills. Yeah, it is an optional components. So if you don't need it, you don't really need to bring it up. But the new CDC is actually in Mills repo instead of like separate repo. Yeah. So one of the cool use cases for Mills is building a global database, like doing replication between two Mills clusters. We already have this support on those cloud, and we are working on a document trying to telling more details about how this is implemented. It's a little bit complicated, but I thought with the existing um, like documents and always open source, it's just still doable. Like you want to do it in the self-managed version, but it's just taking you a little bit more effort. Yeah, and I think in the probably in the next couple release, we also support incremental backup because we see data grows 10 times in the last 1 or 2 years. Like we see like 10 billion use cases, and right now the backup, especially for the full backup, is just too slow for many of the data set. Yeah, so we're working on this incremental backup and snapshot, and hopefully that could be part of 3.0. Okay. Last thing is our context data lake or multimodal data lake. Yeah. So uh, next month we have a big launch, but this is already part of the codes are already on 2.6, so I really want to mention this quick. So two typical use cases. First of all, support accelerate your data lakes, for example, your Iceberg and Delta Lake. What we do is actually instead of ingest all the data into Milvus, you can just specify a data lake collection as an external data source, and then Milvus like read all the data from Iceberg and build index on top of it, so you can directly search your data in Iceberg. And the other interesting use case is when you do data like feature engineering, or then you want to do ETL, um, you can use Spark to manipulate data inside Milvus, directly read our storage, doing all the data preprocessing. Like one of the use case is when you add column, you want to backfill data, and you want to do a join between Mills data and probably from the other table, like from your Iceberg or from your MySQL. You can always do it with Spark. Yeah. And the cool part is not like mainly built for structured data. So you can also do it with unstructured data. So we supported some of the operators like deduplicate all your data, clustering all your vectors, doing anomaly detections. So all those can be run on both Spark and Ray in the future. So in 2.6, we actually changed our storage format. So and it can be easily read into Apache Arrow format, and using Spark and Ray, you can easily processing Arrow format and did a lot of the like for example, if you're running a if you want to running a UDF, or if you want to running an embedding generation, you can just use Ray to read Mills dataset and do all the embedding generations and read back to Milvus to do serving. So I think in the future we're going to support more and more operators and also more systems. And the best part for Milvus Lake is your serving or your Mills databases and Mills Lake actually share the same storage and index, so you don't really need to duplicate your data into twice. Yeah. So what we want to deliver to everyone is more like first of all, it's one data. So no matter your data is in Iceberg, no matter your data is in any kind of the other data lakes, we don't want to copy all the data, and we build one index on top of all the data. So we then when you do any kind of agentic use cases or when you do your data processing, you actually build one data layer, one semantic layer with both your embedding and your tag data. Yeah. Okay. Uh, I think that's pretty much what we want to share. I'll get to take questions. Try Mills if you're interested in trying Milvus 2.6 on this cloud. Um, we do already put 2.6 into GA. So if you're like manage Mills by yourself, we also highly recommend you to upgrade to latest version of 2.6. If you're hating to any issues or if you want like any more details about Mills 2.6, feel free to book a free session, one-to-one session at our office. Our people in the community definitely got to help on your use cases, and we definitely got to hear more about your use case. Yeah. And also for sure join our Discord channel. Feel free to chat. We have a couple of engineers who's a big fans on Discord. They are very active, so don't feel free to ask any questions. Yeah. Okay. I think that's pretty much I want to share. So let's probably go back to questions.
Yeah, thank you very much, James, for the very detailed rundown of the whole presentation. And also, we're very excited for the Loon like release. And we have some questions in the Q&A session, and there's somebody who raised their hand, and I'll allow them to talk.
Okay, let's start from questions. So where can we download this presentation file? Jenny, do you get the answer for that one?
Yes, we will be sending out a email afterwards with the webinar's recording and the presentation inside. So yeah.
Okay. Uh,
And
okay. So second question for now, Woodpecker is embedding in streaming node with memory buffer mode. Yes, the answer is correct. We're going to open source the current buffer mode soon, but right now it's still memory buffer mode. Help you to use it to manage. If you want faster performance for 2.6, I would still recommend to use things like Pulsar or Kafka. Um, yeah, but the other way you can do is always like still using memory buffer mode and tuning the um like buffered window. Like you can probably tune it from 200 milliseconds to 50 milliseconds and using batch ingestion, because even on the buffer mode, the throughput is pretty good. It's just like latency is worse than using Pulsar or Kafka, just because we do a group to reduce like TPS written to S3. Yeah. Okay. Yeah. And for other questions, how about audio? Any recommendation for chunking? Um, yes, I think audio. First of all, you can you the easiest you can do is actually you can converting audio into text and do semantic text chunking. Mm, especially if you're doing things like podcasts, I think many of the cases you can just converting all the audios into text, and the accuracy is pretty high if you're using models like Whisper. Yeah. The other thing you can do if it's not only about like human voice, then I think what you can do is always just randomly uh, cutting like by every frame like 10 seconds or 15 seconds. That should be working as well. Yeah. Struct pattern, is there a migration pattern? I think unfortunately I don't think so for now. But I think that's a good suggestion. Um, you can probably can do VTS, like our vector transmission service. So we probably need to do a little bit like schema optimization of schema change before the migration actually happens. So I don't think we can do it for now, but yeah. Uh, the other way you can do is just using Spark to read all the existing data and write it to a new collection. Yeah. If I have a collection with vector and scalar column, and can I add more scalar columns? Yes, you can add all scalar columns. That's exactly what we support in 2.6. Yeah. And how is index will react? Index is still going to be available for existing scalar data. And if you want to add a collection to add a index to your new uh, adding columns, that is, yeah, you can still do that. So what you usually do is actually adding a new column, and you want to specify whether I want to. No, if you don't have the data, you're really just adding a null column, or you can add a default column. Sometimes you already have the data, so what you do is add a column, backfill all the data, and add index on top of it before you search. Yeah. So schema, you mentioned Asperg and Spark. Do you mean it can be dynamically like a schema evolution? Just happen when you push new data has a new column. Yeah. So when we work with iceberg, what we actually do is create index on top of an iceberg snapshot. So if you keeping just new data or fresh data into iceberg, we actually cannot see the change. So, but we do have a refresh collection interface. So what you usually do is you create an index on top of one snapshot of iceberg, and maybe after one day, you get a bunch of updates on Iceberg and you want to refresh all the data, you should actually call the refresh API. And if you call the refresh API, then if your Iceberg has new data, if you do schema evolution, then Milvus will automatically update with the new Iceberg like a schema. Yeah. Okay. So about the duplication logic, can I do duplication with batches, like one vector group with another? Yes. So there are actually two modes. One is running it in a batch. So that's why we introduced Spark connectors, and Spark can help you to do large batch implementations. Like if you try to duplicate 1 billion data set, um, and you can also do streaming duplication where you have a 1 billion data set and you have probably 10K documents and you want to see if the 10K is already duplicated with my larger data set, then that's why you have Milvus to do like streaming duplications. So you have to do production environment. You have to do both batch duplication using Spark and using Mills to do stream duplications, and it can be combined to work together, share the same data. We'll actually have another blog post talking about. We already have a blog post talking about how we do streaming insertions, but we'll definitely give more details about how to using Spark to do batch duplications. We work with one of the largest AI uh, like model vendors. They have around 20 billion vectors and they do duplication between 20 billion and 20 billion data. So we'll definitely read the blog post talking more about how this can be worked together. Yeah. Okay. Uh, General questions about building hybrid search and re-ranking in comparison to Vespa. Uh, The first part is recall. Do you support a way to supply hybrid formula, for example, zero point 0.5 multiply BM25 sparse score and zero point 0.5 multiply dense score? Yeah, the answer is yes. So for re-ranking, I think we introduced a new model re-ranking, but we already supported multiple different ways to do re-ranking. One of the easiest ways is RF. So the other way is weighted ranking, which is exactly what you are talking about. You can give weight for both sparse score and dense score and combine all those scores. Yeah. Precision for multiple re-ranking stage, is there a way to like let Mills serving re-ranking models uh, and rank the top key result from the hybrid search? Yeah, that is what we have in 2.6, the re-ranker model supports. So check our document. If you have your own existing inference engine, you can integrate with your own, just add a new function, or you can directly call in Cohere or like other model vendors like WoyalGAI. And Mules can also help you to host a model. Like we do support BD re-rankers, we do support Coin re-rankers, multiple different re-ranker support. Yeah. Uh, Is Milvus a preferred partner of NVIDIA? I have seen it utilizing a couple of NVIDIA bumpers. The answer is yes. Milvus is like the first GPU, the first vector to support GPU, and also we are super exciting that NVIDIA becomes one of our paid customers this year. So the answer is yes. We have a strong connection with the NVIDIA team. And we also working with them on like push the boundary, like how to improve GPU index and put into real world production. I think next quarter we will also have one launch on NVIDIA GTC and probably going to show you more about how GPU can be working together with our vector database. Yeah. Uh, so next question, we run Mills distributed on Kubernetes Azure. After running some time with loading many collections partition concurrently, Mills becomes unstable and eventually goes down. It only recovers after we delete the data and start fresh, which called data loss. In a production setup, what are the best strategy to prevent this, especially around limiting load collections, memory sizing, and kernel's data nodes, and a lot of tuning stuff. So, uh, I, uh, I don't have too much details yet. So feel free to open a GitHub issue, like for any people who are actually hating into stability issues. You have multiple different ways to solve that. One is to open a GitHub issue. The other way is join our Discord and asking questions there. And the third way is having an office hour with us, like one-to-one sessions. We definitely got to help uh, any like open source users. Generally speaking, I think you want to make sure that your collection is below 10K. We did some optimization. So last year, we one of the biggest feature we have is increase the collection limit. But still, like if you have too many collections, that becomes a really headache for us. If you do multi-tenancy use cases, you might think about using partition key instead of doing multiple collections. And if you do like have a lot of data inside each of the collections, maybe don't do load and release manually. Just use a tiered storage feature. So we help you to do all the data swap in, swap out. So it should be more stable. But if you hit into any issues, please feel free to share logs with us, and we definitely get to investigate and help you to solve that. All features on Zilliz, when is the GA? So the GA happens this week. So you should be already able to test all those features, and we have full documents ready there. Yeah. What about using ingesting XML files as source of the metadata and documents? Um, we don't have support for XML. For now, we do support CSV, we do support pandas, Paraquet, several other format. Um, I don't know if there is a like standard XML file format. Adding a new format is not like that expensive for Milvus. But yeah, feel free to give us a GitHub issue. Like, see, we need more details about what kind of XML files, what the format looks uh, like especially how embeddings can be stored in this XML format. Yeah, because we right now like we're still very focused on embedding data, and if the data itself don't support embeddings, it doesn't really make sense for us to like ingest those data. JSON, any size of two size limits on JSON type, you can always change it by your a config. Right now the limitation is 64K, but feel free to change it to 256K, but definitely not too large. Like if it's more than 1 MB, so we see multiple issues there. But enlarge it a little bit should definitely be fine. We're working on a new data type called text, where we can support up to 10 MB of data, but that is usually used for store original data chunks. Yeah, I think for meta information, 256 is definitely good enough. Yeah, if you want to store chunks, then text is probably going to be a better solution. Yeah. Woodpecker can be tuned on Zilliz. Are you handling that? Yeah, we are using Woodpecker on Zilliz, and if you're using our fully managed solution, you don't really need to worry about anything. You get better performance with less maintenance cost. Yeah. So with 2.6, is caption load still required after ingesting data? The answer is yes. You still have to load the data, but after you load it, if you don't have enough memory, then what you can do is actually enable this eviction mode. So if you don't have enough memory, we can help you to evict some of the data, so you don't have to do load release manually and load again. Yeah. Uh, I've been using open source for a few months and very impressed with its performance and rapid pace of new features. Yeah. However, I still lack experience in tuning mirrors for production workloads. It would be really helpful to have a documentation or guide or on production best practice tuning tips. I understand there's operational knowledge may overlap with this management cloud offerings, but at any high level, non-business sensitive best practice you can share would be greatly appreciated. I think we always wear two hats. Like I'm not super worried about like the conflicts between our managed service and fully managed service. We do have several like the major difference between our open source version and managed version. So um, yeah, I think it's a good idea to share more guidance. We do have like several performance optimization guidance documents. We should definitely share this with the community. And we also like keep improving Milvus to make sure it's much easier to understand. Yeah. Um, I think maybe next session we're going to talk more about how to improve performance on Milvus, especially for 2.6. Um, Talk about some general rules like probably you need to increase the segment size, what kind of index you're going to be built. So if you are interested, definitely uh, you can leave our message on no matter it's LinkedIn, in GitHub, Discord, and if yeah, we want to hear about what people are actually got to learn, and uh, our marketing team is actually ready to build more like webinars for open source users. Yeah. You mentioned full text feature requests phrase matching. Does Milvus Product Direction aiming to make it fully compatible with Elastic and OpenSearch in the near future? That's a good one. I won't say we're ready for become an alternative for Elastic OpenSearch. We see like so many features supported in Elastic, and they actually built this very complicated system in the last 10 years. But we see strong requirement on like hybrid search, full text search, and things like highlight. So I would say yes. We want to have better performance than OpenSearch and Elastic for now. That's a major goal, and that's mainly for reg use cases. But we are also trying to add in new features that Elastic supported. For example, 3.0 will have aggregation features that will. So we already have geolocation features. We already have like several cool features. Next version will have customized dictionary, so you can configure your own dictionary. So that's also a very common pattern for when you use Elastic. So I would say we're trying to introduce more features, but I would say it's still too early to see Milvus as a alternative for Elastic and OpenSearch on full text search field. Like we are still kind of like very focused on embedding search. You mentioned that highlighting feature uses semantic matching. How is the feature implemented using some language model behind that? We actually train our own models, so you're definitely going to see more details in the future. Next week, I think probably next week we'll have this blog post. Yeah, we actually train a model, so it's basically a re-ranking model. So we fine-tuning the re-ranking model, so it actually not only output the score of relevance, but it also output the highly relevance offset for this document. Yeah. So with the new highlighting model, you can not only like use it as a traditional redirecting model, but you also give you the highlighted part. So you can, if you want to save your tokens, you can only send the highlighted part into larger models instead of sending the full context because sometimes the chunk could be relatively long and only part of the data is actually related to the question. So our original what we do is actually search the chunk and send the whole chunk into learning model, and I don't think it's necessary. Yeah. I might overhead it, but was the question about audio answered? Yeah, I think I kind of like answered all the questions. So for if it's like things like podcast, we would just recommend to converting those audios into text and do the processing like a text rag. Yeah. Um, I'm not a like expert, but on audio process, but yeah, feel free to leave us a message on GitHub, and we have several like algorithm engineers as well, and they can help you uh, to recommend like you need to let us know what is the best, what is the use case for your audio like and we can definitely help you to recommend several models. Yeah. Okay. I think we kind of like already running out of time, so thanks for the interest. We got so many questions, so I'll try to like answer every questions, but yeah, do feel free to leave if you have other things. The other questions, are there plans to supporting storing Woodpecker logs in a separate S3 bucket from the data index to maximum Milvus S3 throughput? That's a good question. The answer is yes. And we are thinking about actually supporting multiple different S3 buckets in the future, like for each of the databases or for each of the collections. Then we can like maximize the overall like S3 throughput, not only at Woodpeckers, but even for each collection, you can have one S3 bucket. So we already supported the external collection. So read from your iceberg. So usually your iceberg is definitely going to be a separate bucket with what you have in Milvus index. So I will say we already have the infras or we already have the code there, but we just need some more configurations to support multiple different bucket. But that's definitely the direction. I didn't say details about Kagura plus Wamana hybrid mode feature during the webinar. Uh, yes, that's a good question. That's something we're going to really launch Q1 on the GTC, NVIDIA GTC. Yeah, so we're going to support uh, using GPU to do index building and serving it with CPU, and that will be part of this code as well. Yeah, so for any of the open source users, because index building is still going to be the most consumption part, and for serving, unless you have too many GPUs, it doesn't really make sense to load all of that into GPU memories. So right now it's more like a hybrid mode. You do GPU indexing and you're serving with CPU. Uh, and the Vimana graph and cover graph is what you're going to support soon. So yeah, we already made some good progress with NVIDIA team, and yeah, we are still working on to make the cost efficiency a little bit better, but I will say from the code side, it's already ready. Yeah. I saw that Pulsar and Kafka was deprecated and replaced with Woodpecker and change it then up and we change it when upgraded to 6. But you said you still recommend to use Pulsar for better performance for now. So we should migrate Woodpecker to Pulsar. First of all, we right now we don't deprecate Kafka and Pulsar. We still using it, we still supporting it, and for the next one or two big release, we'll still going to using Pulsar like as one of the options. Yeah. So for people who are already using Pulsar and Kafka, don't worry about doing the migration. It's not the time yet. But if you're already using Woodpecker and you're satisfied with its performance, I don't think there's like reason you want to migrate back because you definitely get a much easier maintenance using Woodpecker, and you should definitely see Woodpecker's performance get improved in the next following launches. We'll keep improving Woodpecker's performance. Yeah. So and also from latency perspective, yeah, Pulsar is definitely better, and from throughput side, I think Woodpecker is already a much better solution compared to Pulsar. So if you're doing batch insertion, you don't really worry about the ingestion like latency. I would say definitely use the Packer as your options. Yeah. We found current request job with streaming node terminated from scale up that it fixed into 6.7. I don't think I have any knowledge about we hit into a similar issues. And it should be always retried. Like when you do upgrade, definitely you're gonna like take see some requests get fails because it take like at least 10 20 seconds on stream node to recover and rewatch all the segments. Yeah, but what usually happens is your SDK should always retried and it gets success. So give us more details on GitHub, and we definitely got to learn more. But we do fix several like critical issues in 2.6.7. For like any versions before 2.6.7, I would say it's still like we keep improving on that. We did some tests on our production environment, but right now like um, for the next release 2.6.8, we detected this to be our GA version of on this code, and we have a lot of confidence. We'll still do like a lot of improvement on the stability and the performance, but it seemed to be 2.6.8 gave us a lot of confidence that we can put into production. Instead of JSON, will there be a token-oriented object notation as well? Uh, this is the first time I heard about this requirement. I don't think this is on our roadmap, but uh, again, feel free to give us comments. Like if you can leave an issue, if there are a lot of plus one on the GitHub, then we'll definitely put into roadmap. Right now, like this is the first time I heard about this object oriented token oriented object notation. I thought it's a great idea. Yeah, I saw people are trying to use a different way to do reduce their cost. But I think for me, I am like the person. I think a larger model is well optimized for JSON format. So maybe people should still using JSON to get a better like answer quality. Yeah. When we try to create a new empty collection, the query are slower, and when loaded, stream node CPU increases and request from client are failed. How to deep dive into this? I think first of all you need to deploy your own observability stack. We need more monitoring metrics. So good part is already say stream node CPU goes up. Then the next question is does it keep like the one of the use cases we saw like CPU goes up is when you have a lot of collections. If that's your use case, like if you have more than 1,000 or even more than 10,000 collections in your cluster and you loaded all of them. We have a fix for that we have a similar use cases, and we saw the CPU goes up, and we already fixed that issues. So if your stream node CPU goes up because you have too many collections, then just wait for our next release, and we should be already fixed that. Other than that, there may be other reasons why your stream node get high CPU usage. For example, you have a very frequent ingestion. If that's the case, probably you just want to scale up your or scale out your stream node. Yeah. Uh, okay. I think we kind of like answer most of the questions. Yeah.
Thank you, everybody, for these amazing questions, and thank you, James, for the answers. It's very thorough and detailed. And thank you, everybody, again, for staying so long with us. And whether you are using Milvus or not, please definitely check out our Milvus 2.6 release on GitHub. And stay tuned for our Loon release in the next month. Definitely check out our other resources if you haven't been able to have your questions answered here in this webinar. We have Discord channel that you can raise your questions, and we have documents on our websites, which is milvus.io. And also sent out a link in the chat area where you are able to book a 20 minutes free session and office hour with our experts to help with your deployment questions. And to wrap up, thank you everybody again. It's been an amazing 1 hour and a half. And happy early holiday to every one of you. We'll be sending out all the materials and recordings of the webinar afterwards in the email.
Yeah, see you at the next webinar. Bye.
Yes, see you there. Thank you. Bye.